Here we go. Well, okay, so I asked ChatGPT, and I think the problem is that ChatGPT is not not an image generating model, so it's just like being dumb as hell. It made this.
They have
There's plenty of image generation models, but I thought if you just typed it to ChatGPT, it would like notice it and switch to one of its image generating models, but apparently they don't.
I think it's supposed to, but do you pay for OpenAI, whatever, $20 a month?
No.
They have a drop down. You can pick the multimodals.
Oh, okay. But yeah, so there's this one, and then I went to an actual proper model generator, and I got 4 that actually look like they're supposed to look. So this is the first one. I said the prompt was something like, give me a picture that looks like lo-fi study and chill or whatever, but for compiler design and chill. And so they got this one. That's the first one. This terrifying.
What did you change the prompt? Did you change the prompt to anime?
No, it just gave me 4.
Okay.
Then there's this one, which is pretty cool, I think, except for the
better.
text not working quite. And then this one.
This one is the same as the YouTube video. There's a YouTube video.
Was it?
Yeah, there's like a loop, like lo-fi music to study to.
Right, there's like a million of these.
Yeah,
but I wanted one for compiler design, and it's got computer stuff, so.
It's not bad. This one's not bad. Of all, I think this is the winner.
All right.
Yeah.
This one just.
It's weird.
It's like a horror film.
Yeah.
All right.
Oh, shit.
We'll go with this one.
So we're live?
We're live, yeah, we're live. I was posting links on various channels and on Discord. All right, cool. So, Ali, what brings you, what do you want to talk about?
I think brings me back.
What did you say?
Sorry, do you guys remember me from last time, correct?
Yeah.
Of course.
Yeah, okay. Yeah, okay. So not much I've done since then. I've just tried to. I've discovered that the standalone example in the MLIR has Python in it, and I've tried to replicate that essentially out for free. And I'm trying to figure out the CMake lists for the Python. There, what does it actually do? Because I have just copy pasted. Yeah. So that's how much progress I've done since then.
So that's good. I think I had this rough plan for today that we were going to do like a live coding session. If you have a question, if you have a specific question, finish that. I feel like I cut you off.
No, not really. I'm not sure how much value is there in understanding the CMake lists.
There's a lot of value there.
Okay. So,
I mean, do you know CMake?
I know it a little bit. Yes, I know it a little bit. Yes.
So there's definitely, I think there's definitely a lot of value. Okay, so if you know CMake, you can read that stuff. Like it's like literally yesterday, I fixed a misconception that I had for like 2 years or like a year and a half because I stayed away from looking at the CMake for one thing inside of LLVM. And then finally I was like, I need this thing and let me look at the actual function. What the fuck is going on? And I'm like, oh, that's how you do it. And it's beautiful. First of all, it fixes a wrong kind of configuration that I had been doing. It's not production code, but I have this nightly build, and in that nightly build, I set some CMake, and I was doing it wrong. so I can just remove that stupid wrong thing. And also, the thing that I needed to do that made me go look yesterday, I was able to do it.
Should we go look at some examples? I can pull
up. If you want to look at exactly the thing, I mean, you don't want to look at exactly.
Exactly, but we can just like do like an overview of the CMake config or some of the like main functions that you would encounter if you're doing stuff.
Yeah. So if you go to if you go to Python/CMake. So I don't know. So here's the thing, right? Like if you know CMake, you can basically just read that stuff and get what's going on. If you don't know CMake, like I didn't know, it's like reading an encyclopedia. Like if you read it for long enough, you'll get the encyclopedia, but it's very, very slow and tedious progress.
Where am I going?
But I know.
Yeah.
I know CMake a little bit. I know. I was talking about the example, the standalone example. There is CMake there. That actually shows you how to create a Python extension for MLIR.
Yeah, it's the same thing. If you go to, if you hit T standalone, you can jump directly.
Yeah, so I was saying I know CMake from previous work, and I know actually how to create a Python extension in the Pybind also from previous work. So, but still
Go on, sorry.
Still that CMake is like, for example, there is no setup.py, in order to create.
Yeah, it's very different. Yeah. So it's way different. There is a Pybind call that is buried somewhere. I know where it is. So this is the thing, right? Like these are all weird functions, wrappers around.
Yes, exactly.
It's a lot of weird stuff because what you're so like add to parent, this is kind of like a re-implementation of the target dependency in CMake. So when you do like target depends X on Y, this is kind of the same kind of weird thing, but then you're like, why? But so I don't have a lot of answers for why, but partially the reason why is because, well, if I'm going to write this function that in the implementation calls target add dependency, maybe I'll call it something different. But so the point that I'm trying to make here is, if you dig deep enough, you'll find just regular CMake. If you go to add MLIR python.cmake, where all these functions are stored, you can look through it, and it's caps. So it's camel cased.
Which function are you looking for?
Any of them. So like declare Python extensions or something. Yeah, like that one. Right. So there's an add library call, right? On 129, there's an add library call, but it's an interface library. It's an interface library, and then right below it, you have this thing where like you set these properties, right? MLIR, so export properties first of all, and then MLIR Python sources type, extension module name, blah 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 blah, right? What this ends up doing is that when the distribution build is done, these things are in the config. So if you look at the distribution, you'll see stuff like this filled out for each one of the extension modules. And then, so if you control F Pybind in here, yeah, there you go, right? So somewhere there is the only thing that there can be, which is you have to call this use Pybind to build a C extension module. But it's actually like 2 levels deep. You call declare Python module, and that calls add MLIR Python extension. So again, like if this was a regular programming language, you'd be like, that's fine. But because it's CMake, it's annoying as shit. Everything's a string, or it's not a string, or I have no idea. So it's really, really annoying. Like if it was Skylark, I think it would be fine. But so by the way, you can, like, I have an editor that you can put breakpoints in here, and that helps. But I stayed away from this for a long time. But if you want to understand, like hey, if you build the Python bindings, and then you have that folder _MLIR, and you have all that stuff that's scattered in the in the MLIR package, and you're like, how does that stuff get put there? Why? Maybe not the why, but like, how does it get from where I see it in the source tree in MLIR/Python to there? You're basically the only way to figure it out is to read this. Like, maybe there are docs, I have no idea. They're out of date. They don't explain all the weird stuff here. And I can tell you kind of a little bit about why once you figure out a little bit about, well, why are the extensions factored, like how they're factored and stuff like this. But right at this moment, it's not super important.
Okay. So, yeah. Yeah. So I'm trying to go through that file essentially to understand what's happening there. I got.
Is there a particular? I mean, so if you can release, so you're able to build the standalone Python extensions, Pybind extensions, whatever, right? And it works for you.
I'm sorry. Can you say that again?
You're able to build successfully, and it works, right?
Yes. And I can run.
So are you having a problem right this moment?
I'm trying to understand what's happening here so that I can extend it. I thought something that I can do that's nice to you guys also to figure out how to make the basic thing work here too. So.
But you don't need to extend I mean, so when you say extend, I mean, you want to add your own module. You want to add your own bindings. You don't need to extend this stuff. Not very rarely.
Yes. I'm saying extending the example like in my fork. That's what I mean.
Yeah. So we should do what I was planning, which is I want to add Python bind to the polynomial dialect.
Sure. Do you want to share your screen?
Yeah. I guess I'll come back to that. Let me tell this guy at work that I'm heading at.
That's the problem with doing it during working hours, is then it conflicts with.
I mean, it's after hours, but God, this shit is so stupid, bro. I've been on this thing for 3 weeks. Still cannot get the thing that I need. It's absurd. How does this company survive? I don't know. I hope I don't get in trouble for like leaking insider. I don't know. You don't know what team I'm on. Something somewhere sucks. Okay. I'm gonna open up C-Line. Okay. So I'm gonna the way we're gonna go first. I'm gonna close all this NDA stuff. That. Okay, and I'm gonna open up C-Line. I have C-Line. So let me see where my wife is so I can tell if I'm annoying. Probably very.
I just want to say, if you guys had another topic in mind.
This was our plan. Our plan was to, because I don't know anything about the Python bindings, and I'm hoping someday I can learn.
This is the day.
Today's the day.
Is arrived. Okay, so I need to hold. Okay, so I'm going to screen. It's fine. Take over. Share a window. Share my editor. Okay. So I'm gonna make it bigger in a second. Okay. You guys can see this? Yes? Don't show this. Okay.
Can you increase the font just a little bit?
Okay, so I'm gonna do it. Let me increase the font. Is that good?
I think so.
It's nice.
Yes.
It's nice UX, although it's not working for all editors. But okay, cool. So let's find polynomial. Okay. Somewhere in the background, some processes are running that are slowing down this thing. Okay, so we have. I need to pull up an example PR that I have somewhere that'll walk me through. So let's see. So the easiest way to figure out how to do this is to hit a PR that does it. In tree, I don't have one, but out of tree, I have one. So let's see. I find this. Go to my own C API stuff. 8 months ago. Not that one either. Okay, sorry. I need to look through PRs. Maybe this actually is stupid because this project already had Python. So what you need to do in order to accomplish this is you need to do two things. You need to add all the weird Pybind stuff, but you also need to add. So the way that the Python bindings work is they go through the C API, right? So you need C API for the minimum that you need a C API for is dialect registration. I know where I have this. I have security sandbox. So Jeremy, I'm assuming you don't have C API turned on.
You just have to turn it on. Is it just config change?
It's a little bit more tedious than that, but it's not much more tedious than that. Yeah, okay, cool. So in another project I added Python bindings for a brand new dialect. Okay, so I'm gonna link it. I don't know, I guess I could share it. You can't see that, I need to reshare the screen. Presenting, entire screen. Okay, so in Erie Sandbox, I don't know where the hell I could post a link, but whatever. Here's this PR, add Python bindings for indexing dialect. I'm going to send this link here for all the, I don't know, maybe add it to summary or something.
Sure.
So you need to add, so you turn on dialect, you can get magical generation for dialect registration. So there's very little of the C. So there's a lot of C++ stuff that's generated from ODS, right? There's nothing generated, nothing C generated from ODS. All the stuff that can be C generated essentially uses macros. So like, yeah, I think that's actually 100% true. So like, none of these files. What did I change? Oops. Yeah, no. So this is where's the TD file? Yeah, this is a TD file for the bindings themselves. This is not. Yeah, so the C API is completely underserved, under whatever. It's malnourished. And it's funny. I sent up a PR to try to change this, and Medi blocked it. Okay. So you have to at minimum have this. So you need C bindings, C API for dialect registration for your dialect. So like the polynomial dialect. And then what do you need? You need.
So what's the new table gen file doing? I see this indexing ops.td
yeah,
in MLIR structured.
Mm-hmm. That's for generating Python. It's for generating Python source.
So is it MLIR table gen, the binary that's doing that, or?
Yes.
Okay.
Yes. Yeah.
Got it.
Okay, let me get there. Okay, so starting with the C, so I'm starting kind of like onion in to out. The center of the onion is the C API. You need 2 of these macros So you need the declaration and the definition, right? Because it's like C, right? So you declare the dialect registration macro thing, and this will unfold in a second. You'll be able to see what it looks like. Then somewhere in some CPP file, some translation unit, something that gets compiled, you need to put the definition, right? So the first one is the header declaration. The second one is, okay, what is the actual function that does the registration? That is a C API thing. That is a C function. And that's it. So this other stuff, I like threw into the mix in the first PR. Hey, I want to expose some values and some types and stuff like this. Okay. After that, you get a C API for dialect registration. That's it. The Python bindings go through the C API, but anything else can go through the C API, right? So you can immediately say, let's see.
And so this is just standard C and CMake. There's no, like, the macros auto-generating some stuff, but other than that, it's just linking it normally to some C.
Normally. Yeah, I mean it's C API, so there's nothing. Well, okay, so the CMake around this is weird as shit if you don't have already a C API, because so where's the
I see the add MLIR public C API library.
Add MLIR. What is that? What are you looking at? Where's that?
In the PR, lib/C API CMake lists. So it's adding. So you did.
No, yeah. So exactly. So no. So we bunched all this stuff together, right? They have at the time right. These are blue. These are not green. They already had this.
They already had that. Yeah.
So I'm just trying
to see how that connects to the dialects.h in structured C. I'm assuming that the dialects.
It doesn't.
No?
It doesn't.
Okay.
No. That header gets included in the. Okay, fine. At this point, I might as well just start going. Okay, so we need. So you need a. Okay, where do people usually put this? They put it. It's like quant. The easiest way to figure this out is, okay, who did it? So let's see. It's under MLIR C, right? So dialect. Okay, first I'm gonna make a new branch. Pybind. Okay, right. So each of these is for a dialect. Let's take the thinnest one, which is not quant, but close enough. Poly. Respect all the conventions, right? So like
a polynomial. They'll get mad if you just call it
poly. Ah, see, there you go. There you go.
They'll hate you if you just call it poly because everything's called poly.
Yeah. And my editor's too smart. Okay, let me delete that. Yeah, I forgot. Okay. And then I got to change quant to polynomial. And I can delete. So, okay, so here's that dialect registration thing. Right, so for the first pass, I'm not going to do anything. I'm not going to expose any of your types. I'm not going to bind any of the types, right? Mm-hmm. We can either do follow-on commits to the first commit, or we can do something else. Okay, so then the naming here is important. This one should be capital. So as soon as I add, so like if I add this somewhere that is an actual CPP file that is actually being parsed. So let's see. So okay, so the Python bindings are a two-tiered apartheid system. I'm being kind of funny, but there are two types of Python bindings in tree, and out of tree you can only be the latter kind. So in tree you have, for example, IR attributes, right? So here's a bunch of stuff that's like. There's affine attribute in here, affine map. There's the basic attributes.
That's because those are all in the built-in dialect, right? Versus stuff that's in.
No, I mean affine's not.
Affine map is, the attribute is.
Okay, is that true? Okay,
yeah.
Maybe. Is that really true? That's in the built-in?
I'm pretty sure it is, because I also was shocked about that.
Okay, but that's not what I'm talking about. I mean, so that's I don't know, maybe that was what they're reasoning in the beginning, but that's not what I'm talking about. You have a bunch of these files that are essentially, so the two-tiered system is that there are files in this directory, which is lib/binding/python, which have access to like lots of nice header utility functions, like stuff in here like PyConcrete type, which is a very nice wrapper around type that gives you a lot of stuff like is instance, a lot of like real stuff on the Python side.
Mm-hmm.
And right, everything in here, yeah. So for example, so I don't know why these are actually here. It's funny. I feel like somebody moved these, but if you look at IR affine, it imports from here IR module.
Mm-hmm.
Well, he dropped off because it's
Looks
getting
like
too
it.
heavy.
Well, maybe.
Or maybe his network connection. Maybe his connection. All right, back. Yeah. Talk shit too soon. Okay, right. So these are somebody has these ordered in the opposite way that you're supposed to order them. Anyway, probably me. So this header, which is here in this directory, has also a bunch of stuff. It has a bunch of stuff in it, right? Py operation, blah blah blah, py type, blah blah blah, right? IR affine. IR affine is not a built-in dialect. Maybe it was there in the beginning, and it like got grandfathered in or something. But these other ones, like Quant, do not import any of the headers that are in this directory.
Mm-hmm.
Not even transform, which is like a darling dialect, right? So this is the two-tiered system. Outside, so in tree you can have either of these, and I'm remembering incorrectly, or just it is what it is. I believe these used to live elsewhere. These files used to live elsewhere. So this directory doesn't have a CMake. There are no targets in this directory, and there are no like. It's not like the CMake is somewhere else, but it doesn't expose targets that you can pull in. So this isn't a library. These aren't reusable libraries. And I've gotten into like knockdown, drag out fights with Stella, and I mean I'm exaggerating, right, for like effect. And Alex about like we should eliminate the boundary, and we should make all the code free and reusable. No, we have to have it private by it's your fault. It's Google's style guide private by default bullshit. I blame you. You're responsible for it. Okay, so in tree you have these two flavors. Out of tree you can only do the stuff that's being done in here. So what am I talking about? Again, affine has failed to pull out both of these. Why can't I see this thing? Okay, affine has. Let's see the type. Yeah. Okay. So like PyConcrete affine expression, and then Py type somewhere. I don't know. Whatever. Just at the minimum, PyConcrete expression, right? So this is a CRTP from here. That doesn't use anything. Okay, I don't know. Whatever. You can create types. You can use these things. So like IR type, right? Py index type, which is going to jump me here, which is inside IR type. Inherits it's CRTP from PyConcrete type, right?
Mm-hmm.
This is the thing that gets you a lot of nice stuff on the Python side. In the second class, you cannot use this thing. You cannot use this nice thing. You have to use an alternative thing. You have to use this MLIR type subclass. And it's like, Max, what are you going on and on about? This is tedious, in the weeds, boring details. It is 100%, but like, if you spend a lot of time on this, which I did at some point, like I wrote a bunch of these, you will very quickly discover, oh, these are not only very hacky, weird things that are much less like commonsensical, like why? What is this? What's going on? They also have less powers, fewer powers. Okay. Back to your story, the Pybind story, the polynomial story. Okay, so you have this header. It needs to be included somewhere. you are not a blessed dialect. You're one of the second-tier citizens. You have to have one of these.
Mm-hmm.
So I'm going to make you dialect polynomial. And I'm going to, let's see, I can basically delete. Before I put the registration. Oh, shit. I'm trying to remember where the registration code goes. Where is the registration code for this? Yeah, so by the way, here's what that macro does. It generates this thing called MLIR dialect handle quant. And the important part of this, as far as like linkage, is the visibility here. So this attribute is important. I'm trying to remember where the hell this is used. Of course, my search is shit. Is it register everything? Register. Okay, one second. I gotta refer to an out of tree example to figure out to remember where the registration is. So that dialect handle gets created, and it's a handle. The word is handle, right? It has to be passed to this registration thing that has a callback and takes the handle. So just don't remember where we put those in tree. Out of tree, you put them directly in the module. So just, yeah, you got a question, man? Nope.
I was going to say in the standalone project, this handle is called by the Pybind module declaration. So.
Oh yeah, shit! I rewrote this. I forgot. Sorry, I forgot. I rewrote this.
So there is a CPP file that essentially is the entry point for the module, correct? And it is the thing that's declaring a function where you register a Python function where you register all the.
So this is what it looks like. This is what it looks like out of tree.
Yeah.
Yeah. But you still have to, right? So this is that dialect handle, right? So this is that dialect handle, except it's written out longhand.
Mm-hmm.
But you still have to do this. Oh, sorry. No. Because you're, yeah, right. You're an in-tree dialect. No, that's not true. That's not true. Sorry. Because the JAX people were complaining about this. Register all dialects. You're registered here. Yeah, right. No, sorry. Yeah, so this is a C API, right? Yeah, so this is under C API, register everything. You get thrown in the mix here. The JAX people are weird as shit. Mm-hmm. Yeah, right, 100%. Yeah. Do you not need that then? Then why does That's funny. I didn't even think about it. So the JAX people are weird. They don't build register everything. But then I'm like, how the fuck? Or sorry, why is this existing? If quant is also gets thrown in the mix, right? Huh. Maybe it isn't necessary. I never thought about this. That's funny. Okay, let's run an experiment. Okay, so I'm gonna delete everything here. I'm gonna delete everything here. You change this, right? Is it dialects? Whoops. Polynomial. MLIR polynomial dialect. And then we don't need this. We don't need this. We don't need this. We do need this. We put that in the right place, right? We'll drop the other stuff in a second. Okay, so right? The header exposes that thing. Now you need to add this file somewhere. Where do you add it? You add it to the CMake that we were looking at just now. Python/CMake, and then dialects. Yeah. So the way that I usually find these things is, okay, so that's main. That's register everything. There we go. Okay, so let's drop you just at the bottom. Sorry, fix this plain text. Okay, cool. And now we change. So you're just trying to remember. This is dialects. Oh, sorry, this is too far down. You want to look like everybody else, you're going to be up here. And this says dialects dot sparse tensor. Okay, so your full name goes here. Then we replace case sensitive. Okay. That fucked up the case sensitivity, but that's fine. So this.
I got line 597 as well. Oh, and 593.
Okay. Yeah. Okay, so dialect polynomial.
And
that's the name.
Sorry, one more.
It's okay. 592. Yes. Yes. Okay. Okay. And here. No, this is the, yeah. So it's, God, the casing is so fucking stupid. Okay, so this name matches here, right? The sources, and there's a game that's being played here because the CMake is not at the root here. So the root, right? This is this weird thing dance. The root dir is here, blah blah blah. The source is here. Private link, that's fine. Okay, that's fine. You probably don't actually need anything to begin with, but this doesn't exist yet. This is the thing that I was saying.
You need a CMake target for that.
You will end up needing. So okay, let's comment this out actually. Refresh the CMake. That'll parse this. That'll parse the header. That'll at least get us started. Did not find target dialects. Okay, add to parent. Okay, so add to parent. Let's find this is declared. Declare Python sources. Okay. Right. Yeah. Dialects. So look down here at complaint. Could not find targets. Right. Down at the, so this is, again, this is the nuts of the CMake. This add to parent, that's a target of a particular kind that has to exist. That target is created here. This target already exists, blah, blah, blah. Okay. You don't need this. Do you have enums?
No.
You do, right? You must.
Nope.
You have no enum attributes? Okay. Okay. And then the minimum is you need a file that looks like this. We'll get to the TD. So yeah. No, shit. No, that's the right one. Right. So this file does nothing except import the C. Okay, a point of order important thing. This name underscore MLIR dialects polynomial is quote unquote load bearing. It's the name that is referenced here. module name is also the name that you wrote here. Got to be very careful about that. Okay, let's see if we get anything else. Okay, I think that took. And then unseen, so there's a little loading bar. Okay, cool. So these are gray because nothing's being used, right? Because we have this thing, but it's all getting parsed correctly now. Okay, so that's generating that handle, blah, blah, blah. Nothing. Should actually be able to compile just for fun. Okay, so let's see. So the target, the targets that are generated here are like wacky, right? This is a target that is the collection of, this is actually, I believe, the actual target, but it's the DSO that you want, the dynamic shared object like that. So if I type in MLIR Python extension, yeah, right. See, okay, it's sorry, I was wrong. The module name is the actual target. Dialects polynomial. Okay, so you can see this, right?
Mm-hmm.
It says in very small text. It says MLIR Python modules dot extension dot underscore MLIR dialects polynomial dot DSO. That's the actual Python extension SO or dialect. Build that. Let's see the builds. Now, of course, it's going to build the whole world. I don't know why it's building the whole world. Because I'm not. Oh, I'm not linking to anything. I don't know why it's building the whole. So that's going to take a second.
Does it have to build table gen?
Well, it's doing that. No.
Yeah.
I mean, there's nothing linked, right? There's nothing linked here. I'm trying to remember if there's something. I mean, LLVM support isn't 3,000 targets. LLVM support is like 100 targets. I'm trying to remember if there's some hidden thing that's being linked there, because I'm not building, right? I'm not building this giant omnibus thing down here. I'm only building your thing, and your thing doesn't link currently anything other than LLVM support. So I don't know. Maybe my cache was. I don't know. I don't know why it triggered a complete.
Well,
so while that churns,
does it build everything that the polynomial dialect depends on?
No, it doesn't even actually know about it yet. Because I only have this CPP file. You have no, right? If I had linked, if this existed, then yeah, sure.
Mm-hmm.
But right now I just have this CPP file. It just imports a header. There's nothing in it. So I don't know. Maybe I blew. I don't know. I did some weird shit. So while it's doing that, 'cause it's gonna be like 10 minutes, I'm trying to think of what I can productively say. So maybe
what's the content of this dynamic shared object?
Yeah, that's okay. That's a good one. That's a good one to talk about. Okay, so it's this. I mean, obviously, kind of like tautologically, it's this because this is the CPP file. The way that I said this in the chat when you asked me about this initially. So this macro from Pybind, let's spill it all the way out. How is that possible? Oh, that's okay. Okay, cool. So what you see here is some of this stuff is still is Pybind, right? But then just very quickly it starts to be just pure Python. So everything, well, okay. So the visibility, like I said, that's important because this is a C. So the Python extensions are C extensions. There's C code and it's C linkage, C calling conventions, all this kind of crufty stuff. So all of it is extern C, but even so, the extern C, just doesn't name mangle. Oh, sorry, I split this function. This is the function that returns a Py object pointer. So this Python will look for, this is a cute trick that I discovered. This file will get turned into something that is called basically this.so, right? This.so. When the Python interpreter loads, DL opens that thing, underscore MLIR dialects polynomial.so, it looks for this symbol, pi init underscore blah blah. What that means is, if you have a name, like the name of the shared object tells Python what's the name of the init code, right? So this is pi init, which means that if one init per SO, typically. Hey, the name of the SO, cool, find in the symbol table that function, call that init function. But you can actually hack this and have multiple inits in one SO if you use symbolic links. So if you have multiple symbolic links to the same SO and you have multiple corresponding inits, it'll work. Okay, that's very in the weeds, but it doesn't matter. It's a fun thing. Think about it. I don't know, whatever. But right. So the point is, the name of the file that is generated from this C extension has to be named the correct thing. And of course, this macro does it for you. I mean, it all generated quickly. And the extern C prevents it from getting turned into something weird. But the visibility is also important. This symbol visibility is more linker crufty stuff, hidden symbols versus default visible symbols, weak linkage, weak symbols, blah, 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 blah. Okay. So this is a forward declaration. Here's the actual implementation. Right, some stuff that's like standard stuff, I guess. So all this stuff is, there is something about ABI, like the Python C extension ABI or something like that. But it's version specific. So like if you build a C extension, for Python 3.11, it'll only work for Python 3.11. It won't work for 3.10. But then they're moving to some kind of model where they have an actual C extension ABI, where if you do build against 3.15, it'll work for 3.16 and 3.17. Like they'll have versions of the ABI, some kind of thing like this. But currently, right, this is just doing a sanity check. Hey, the current version. So this is a runtime call. This is init code that's called at runtime when you load the module. This is doing a sanity check, like, are you loading in the right interpreter? Mm-hmm. And then there's some other Pybind kind of utility convenience kind of wrappers around. So this gets turned into a module. This gets turned into a Python, right? Like when you see this in Python, this is called a module. There's functions in it. There's classes in it, right? Like you can pull stuff out of here, right? Mm-hmm. So that's in the ontology of Python stuff. This is a module, and I'm importing everything from within that module. Okay, this is basically doing the exact same thing. It's creating one of these, but whereas you would write this in Python, and then the Python interpreter will read that source and then make that thing, you can do the same thing by saying, hey, Python interpreter, please make a module with name such and such. Mm-hmm. Please put such and such things in it. That's all that's happening. And in like the Python docs, they'll show you the longhand way of how this works. Yeah, that's basically what's happening. It's a bunch of like C kind of crufty things, like put an array that is length 5, and then the second, third, and fourth entry are function pointers. So it's all C programming, but it's doing kind of reasonable things. It's like associating the the name of the module, the location of the module, stuff like this. All the kinds of things that you can query about this any one of these modules, you're basically writing those out longhand in C. Okay, so that's the answer to the question of what's the content. That's the content. It's like materializing it's materializing what this looks like, which it is, just on the Python side. Mm-hmm. It's making all the same calls that the interpreter will make when it parses this. You're just doing it by hand. Mm-hmm. And it's all, it's all hidden and like wrapped and blah blah. Okay, so we'll come back to these. What else to say? Okay, so what are these? You don't have one of these, but let's you don't have one of these yet, but let's add one. Because the key thing, right, is so these bindings, these Python bindings, that's actually kind of like a misnomer. If you were to be very pedantic about it, what I mean by that is the indices, blah 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 blah. I was telling myself when I graduated, I would buy like a $10,000 computer so that I never had to wait for this.
Dude, the problem is, the more powerful your computer gets, the more cruft they add.
It's Malthusian.
How is this not
program.
async?
I mean, this is JetBrains, and yeah, I don't know. I mean, JetBrains tools are pretty damn good, but sometimes it'll like having Chrome and this going at the same time will eat all the resources. But you can't blame it, because what is it doing? It's indexing. So what is it doing? It's indexing the entire source tree and also the build directory.
But it's not, I mean, like, it's not just shelling out to like ClangD, it's got its own custom thing.
They recently transitioned, so they had a fork, so it definitely wasn't shelling out, but they had like an in-process instance of ClangD that was their fork, but they recently moved away from that. Now they're using like ReSharper. You ever heard of that? Mm-mm. So they make tools across the language blah 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 spectrum. One of their best selling things is the same kind of IDE for C#. And for that product, you can get the IDE, you can pay whatever the hundreds of bucks for the IDE, or you can get a plugin for VS Studio, for Visual Studio. Because a bunch of C# people are like Windows people, so they use Visual Studio. And essentially the back end between the IDE, like it's always been the case for the C# product, that the back end behind the plugin and the back end behind that IDE was this thing called ReSharper, like C# ReSharper, I don't know. And apparently that they've like extended that, generalized that, such that they can now use it for CPP static analysis too. This is ridiculous, right?
Is it because you're building at the same time?
I mean, for sure. So I can kill the build to recover some sensitivity. Or I could kill ClangD. Kill the build. What else? I mean, let's see what HTOP says. Whoops, shit. Okay, calm down. Didn't kill. Come on. There is a way to like force it to stop, but I might have to kill it. I can also kill ClangD. Jesus Christ. Okay. Fuck it. There we go. Okay. What was I saying? Oh, I was saying about the table gem files. So the calling, it's on the wrong fork, or it's on the wrong branch. No, it can't be on it just hasn't updated. Okay. I was saying that bindings is kind of like a misnomer. The reason it's a misnomer is because, like, what is a binding? A binding is I call a function like Rust. Like if you bind to the C API of something in your C++ program, you have a C++ function that calls a C function, right? Or vice versa, whatever it is. But you have like it's like a call time thing. Like the word bind, like the binding action happens at call time, or it compile. I mean, it's not a compile time thing. This is why I think it's a little weird. But maybe I'm wrong. But anyway, so what I was trying to say was, let's see, okay. This is not it. I know I need to make it bigger. Okay. Okay. So if you look at PDL ops, there's nothing in here, right? The reason there's nothing in here is because it doesn't matter. The include is transitive. So that's why nothing. It doesn't. It's just an include. It's just a trick. All right, made it. Whoops. Okay. So change PDL to polynomial. Let's see if this will work. No, didn't work. You'd have to go over the spelling with a fine tooth comb. Why isn't that working? Jesus Christ. Okay, that's what I wanted. So that I could just only cap this. Okay, cool. Is this where your thing is?
It's just called polynomial. It's just called polynomial.td.
Okay, like this.
Mm-hmm.
Okay, cool. This then is referenced. Actually, I think it's automatic, unless you're unconventional. So let's see, it's a TD file, right? Let's see. Okay. Yeah. So we added this, but we didn't add one of these, right? We didn't add a TD file, and here we can now add it. Lots of people call this ops. It doesn't really matter. And there was some discussion where we would make these go away. We tried to make them go away, and then there's like a to-do about maybe they'll go away. Okay, so this is where the binding action actually happens. What happens here is this TD file will be read by MLIR TableGen. That'll include all of this stuff. And by the way, right, if this is your root TD file, right?
Yep.
Does this have all your adders and types and everything?
Yep.
Yeah, cool. It'll get parsed, and as soon as it's parsed, the TableGen blah 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 in-memory representation of all your ops and types and stuff will see all that stuff, and then we'll iterate over your ops, and dump out a whole bunch of Python. Right, for every op, it'll generate some weird Python. Okay, so let's do that. And this is one of those things that, like, it's like all the TableGen stuff is really, I think it's useful to find in your build system. I don't know how it works in Bazel, but like Ninja or Makefile, how is TableGen called? What are the arguments to TableGen? Mm-hmm. Let me try to make those calls by hand, and instead of going to a file, just dump it to standard out so that I can see what's going on. Like, it's just so that it takes away some of the magic. Hey, it's just generating a whole bunch of ass ton of C++. using this declarative spec that's whatever.
And so
Smart,
this
weird,
is also like a leaf node of the build. This doesn't need any of that other stuff we did with the C declarations yet. This is just generating Python text. Yeah.
No. Yeah. This doesn't even build anything. It just calls table gen. It doesn't even compile anything, because so here's the thing. This is why I was like, this is a little weird. It generates Python. That Python's only ever read. I don't know. Maybe I actually said it backwards. Like the binding should be at compile time. This ends up being a binding at runtime. It's weird. Okay, let's do that again. So this is a different target, right? Let's see. Sorry, let me stop this. I forget what the target here is. Yeah, what's up?
I just didn't catch. So it's going to generate some Python code.
Yeah.
I would assume that's going into the extension. But I don't understand the Python code that's being generated by TableGen, when it would be used.
Yeah, I'll show you. I'll show you in just 1 second. Trying to remember which of these targets is the one that actually does the TableGen. Maybe, yeah, running utility command. That's probably it. Okay. So let's see. Okay, so this gets dumped deep in the build tree. Blah blah blah. MLIR, Python packages, dialects. These underscores are what are generated. They say gen, right? Ops gen, enum gen. Okay, so let's see. Did yours pop out? No. Shit. Why? Am I looking at the wrong place? No, let's see. No, here's code. Ops gen.
Does it have to reconfigure because you changed the CMake files?
I did it though.
Okay.
Yeah, I did it. Where the fuck is CMake? It's weird. I got a loading bar, but usually I can't. It's not showing me that. That's what I want to see. Yeah. So this is a symlink. This is not what I want, but this is like the vicinity. Is DSO.
Well, that's not the TableGen command, right? So this is the wrong target.
No. Yeah. But I don't. But it's an 80 meg file, and tools Python. It's probably this one. OpsGen. Right. Yeah. This is why is. Can't drag the windows and see more. Shoot. Go ahead. Oh, dialect name. Yeah. Okay. Right. Well, this is definitely an important.
You'd think this would have like an error in the CMake config if it can't find these.
No. Yeah. That'd be great. But I forget when we need dialect name. Is your dialect name Polynomial, not Poly? So this is an argument passed to TableGen. But this is, I guess this is only important if you have.
If your dialect pulls in multiple,
it
can pull in like types or attributes for multiple dialects, and then it would be confused about which dialect to attach it to.
Yeah.
I've noticed you can specify that for everything except ops. So if you're in TableGen and you pull in a different ops from a different dialect inadvertently into your TableGen, it will generate those ops, and then it will crash because like the namespaces won't be set up correctly.
That's true. I feel like I've run into that before, but I don't remember exactly. Why the fuck? What am I missing? Because I definitely need an ops gen for this, yes. But there's something I'm missing because I do not have ops gen for. Oh, I no shit. But also, it's possible that I do, and I just can't see it. So no. What the fuck? Huh. What am I missing? I must have missed the target actually somewhere. Bindings.
Declare MLIR dialect Python bindings. I'm looking at the TableGen right now.
You have a voice like somebody on NPR.
Oh, thank you.
I'm looking at the.
That's so kind. Yeah.
I'm not even being sarcastic, bro. Did I name it wrong? No. Wait. Yes, I named it wrong. That's why. Yes. Yes, I named it wrong. So this needs to be. So these are sources. This needs to be here. Yes. Yeah. Ah. It's usually that. It's usually that you name it wrong. So let me put it here.
It's good to know this isn't only a Bazel problem.
I mean, build systems are like notoriously hard to get right.
Build systems are so evil.
Yeah. Okay. This is. Okay, what is this? Add to dialect, transform PDL extension. Okay, cool.
But I thought Bazel would give you an error, correct? Bazel,
I like
like
Bazel,
calling the function.
Yeah, it's actually
it's like you are calling a function. Yeah.
It's
true. Here it's.
But a lot of the like things that are generated are just like arbitrary strings, and if you get the names wrong, it won't be able to find anything, and there's no way to get a hint as to where it might be. And there's lots of like path issues too, where it's like, okay, what's the like, everything is supposed to be kind of absolute, but a lot of, in practice, a lot of it is like, oh, are you relative to the run files directory versus the source directory versus whatever.
Yeah.
It's equally a mess, I think.
Yeah. I ran into that accidentally. Yeah.
No, go ahead.
I was just going to say I ran into that in the tutorial that you made, Jeremy, and I spent like a couple of hours on that, and then I saw that somebody opened an issue where you need the specific Bazel version. I was like,
okay. Sorry about that. I think I added something to the Bazel RC that forces a minimum Bazel version, but then the problem is I can't like retroactively do that to all the previous commits because it breaks all the links in the tutorial to the commit hash.
Yeah.
What did I fuck up here? Where's this page? What the fuck? What? I have Python sources, dialects. I'm spelling something wrong. Gotta be spelling something wrong. This is a target. What am I? Cannot find a dot. Perhaps it is not bullshit not yet been created. Where is this created? Let's see. Oh my God. Okay, that's configuring. Okay. This is a legal thing. Edit. Grab this. Add to parent. My high, what is missing here? Not gonna work again?
I think there is another target for the Python sources, correct? You need to create the Python MLIR Python sources target. Did you do it?
Yeah, I don't think so. Because if you look at this seemingly creates the async target. If I like control click, I'm sure it'll take me there. Declare, yeah, right there. Yeah. Yeah, so this declares a dialect target. Yeah. The dialect target, I'm parsing it wrong somehow. Dialect name, that's correct. Something I'm spelling wrong. Is it a capital? No. Okay, let's do this. Let's do this. Put that right next to each other and leave them ugly for a second. Okay. This is the name of this. This is add to parent. Dialect name. Bananas. Okay, let's do this. Let's use the power of the fancy editor. Okay, cool. So we have targets. We do not have. Why do we not have polynomial target? We have func. We have func. There's something really wacky. Okay, so let's copy this. Let's remove this for a second. Breakpoint here. Okay. Polynomial. PD.
Or what did you call the TD file? Because this is the TD file you made, not the TD file.
Yeah, it's right here.
Okay.
Yeah, it's right here. And then you have TD. Okay. Fresh. This is almost exciting as our first brush with Python bindings.
Right.
No, this is, hey, at least I know my way around this thing. Okay, targets. Polynomial, upstream. I have no idea. See, I have no fucking clue. I swear I was spelling everything right.
I know my way around my stuff. I just don't know my way around other people's stuff.
Yeah. Okay, so it's buffering. Yeah. Cannot find beautiful. Where is this? Right. Python source. What the fuck? Did I name it something different? Oh my god. Dialect quant.
This is gonna be a dumb question, but do you need to indent it after sources?
Do I need to what? Do I need to what?
It's indented. Well, okay.
The indentations.
I didn't think so.
Okay. Polynomial. Lowercase polynomial. I don't know why I keep on doing it. I swear that was the exact same thing I had before, but okay. How the fuck is that possible? Why is it saying that?
So wait, this dialect polynomial CPP. This is
I know,
MLIR / Python, whereas the dialect polynomial created is in bindings / Python.
Yeah, I know.
It's moved around by.
I don't know. How is this? No, it doesn't. But how is this possible? The root there. Am I high? That's clearly right there. Right? I'm not. What am I looking at? There's some fuckery going on. No, that's today. What the fuck? How is this even working? All of these, as you rightfully pointed out, where? Sorry. Dialects. Dialect EDL LCP. I cannot fathom. Okay, let's kill this for a second. Because you don't actually need this for timing. I can't fathom how that's possible, but. Okay, so this thing is generating. Okay. Oxygen. Polynomial oxygen. There it is. Okay, so this is the target that builds that runs table. Okay, cool. Fuck, at least some progress. Okay. So what it generated was a whole bunch of trampolines, essentially. Oh my god.
It's not there.
No way. Okay, so this is now definitely fuckery. Yeah, this is there. It's just the directory hasn't refreshed.
Oh, it's the file browser.
Yeah. Yeah, that's wild. It's there, but no, that's not there. Actually, there you go. Sorry. That's the install directory. It's here. It is. Come on, don't let me down. It is not there. That's not what am I looking at? 100%. Okay. Shit. Let's do it. Okay. I mean, whatever. I don't know what the fuck's going on there, but this is what it generated. Right? So these are all your ops. They look familiar, obviously, right? Like from TensorOp, blah blah, int TT. What the hell is int TT?
And and inverse NTT. It's like a Fourier transform, but integer only.
That's a bad name. That's a bad name. I love you, but that's a horrible name.
Hey, it's not my name. That's the.
Yeah. Inv TT.
Inverse,
TT.
But anyway. NTT. Oh, you think it should be renamed Inv NTT? Not bad idea.
Yeah. Okay. So these are all trampolines. I call them trampolines because you pass in stuff, right? But the real construction happens in the Python bindings infrastructure, right? So this is a call to something self-build generic. Self-build generic is not a Python function. This is implemented in the infrastructure bindings. It'll build you an op, blah blah blah. It'll call the C bindings to op.
This is like operation
state.
Yeah,
all this kind of stuff. And then it'll wrap it in a class, and then that class will be cast, blah, 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 blah. So this is code. This is real code. Like if you put a breakpoint here during, so Ali, this is a question. This is an answer to your question, right? Of like, what is it generating? What's going on? If I call this function somewhere by passing in these are SSA values, the input, this is a type, the output is a type, input is an SSA value. You'll step through this function. You'll get operands, blah, blah, and then you'll call this thing, which jumps back into C++. And then the result is an instance of this class. The instance of this class will have a handle, like you can grab the operand 0, you can grab the result type. There are two callers. There's two ways to call this. You can either call it by calling from here, from the class constructor, right? Or you can call it from here. This I added last year. The only difference here is this will give you an op. This will give you the result value, right? So the annotation here is accurate. This literally just calls the same thing but gives you the result value. And these are the bindings. So if you want to write polynomial dialect in Python, this is what 90% of what you're doing. And actually, I think this will probably work, right? Because you don't actually need an extension module. So the fact that the thing is mysteriously not working, we realized doesn't really matter. The only thing that you have to do is this. You change this module to just import from polynomial ops gen import star. So a bunch of these already have, for example, like here, right? So they're all red because the files aren't here, right? But when you build, they'll be like smushed together. Let's see what the simplest end-to-end walkthrough example. So we can put a test. Python tests.
Well, so I have a dumb question. What are we not getting if we don't do that extension library?
You don't get any type bindings. You don't get any type bindings. I'll explain that.
Okay. But so you like if you run it then and you look at the output types, they will just be like
no you'll see them. You'll see you'll see them. You just can't create them.
Got it. Okay. Huh.
So this is important for this little example. We have a context, blah blah. That looks blah blah blah. Context. I need a module. This was a bad one to copy. That's fine. This. This. So, right. So if you don't bind the types, this is what you have to do.
Okay.
You have to parse. Yeah.
That's not too bad.
It's what? It's offensive. Okay. Give me
if you see the types in the polynomial dialect, you might agree it's not so bad. I prefer the.
Well, one thing that I'm hoping to have some time for is some kind of like SymPy-ish affine. So you know how the affine symbols they overload add and stuff like that.
Mm-hmm.
I'd like to be able to put something together like that for you, so that I can write the polynomials without. So your polynomials are in your types, right?
Mm-hmm.
The actual like the monics and the cubics and stuff, they're in the types. The ops operate on them. I have to write types if I want polynomials.
Right, exactly.
Yeah. So I want to put some. Okay. So give me an example of a thing that doesn't. So typically, right, you need a type for a bunch of these ops. Can you give me an example of an op that uses one of the built-in types to define whatever like necessary, the result type or the input type or something?
Like from tensor?
Yeah, sure. But you need a result type.
You need a result type, yeah. I mean, I'm not sure if any of the ops don't need a type in the input or the output.
Do you not use type inference anywhere? Okay, so the answer is no. I guess you would know off the top of your head. Okay,
yeah, I don't think
degree,
so.
Right? Leading.
Degree.
But I can't because I need an op. But I need an op. Yeah, so those are numbers, but what is this? Shit, bro, you don't have like from list?
We need from tensor. You mean from list? Like you're gonna need a polynomial. Anything in this dialect is gonna operate on the polynomial type or produce a polynomial type.
Sure, fair enough.
I mean, can we just parse it from MLIR text? Just
yeah. Why not?
I can.
Let's do it live. Okay, so from tensor, I need an output type. So output equals this is a type. Yeah, it should be whatever thing. And then I need input tensor. So input will be a tensor. And for that, we have. So I need a value, right? This is a value. Yeah. Tensor.empty. From MLIR extras. Import types as t. Tensor. Trying to remember. So what does this tensor have to look like? ND, not ND. What list?
Just one dimensional I32s of whatever size you like.
And then the output, did you paste it?
I sent it to you in chat, yeah.
Okay, cool. Let's get rid of this shit.
Actually, depending on which commit you're on, I just merged something that actually changes the syntax, so.
Well, so this won't actually work because I didn't rebuild all the way.
Okay.
Yeah, now we're back here. Anything. So
like, what does it do for like if the MLIR has like custom parsers for like attributes or types or ops even? Like, how does the Python bindings make sense of that?
Attributes and types, nothing. There's nothing there that's so the only bindings that are automatic in this way are ops. There's only stuff generated for ops, right? You can only get automatic call this function, get an op for ops. There is no generated call this function, get a type. There is no call this function, get an attribute. There's a bunch of handwritten implementations for built-in attributes. And then there's a whole bunch of handwritten built-in implementations for like get an I32, get a float 32, get a rank tensor type. None of those are generated. They're all handwritten and then calling C APIs. And like the asterisk on this is literally this week I sent a PR to try to start to get a move on generating some of that stuff, and then Mehdi blocked it. But like Jacques and I have been talking about this for a year. And like now I have time. Now I'm not a PhD student. Now I can actually spend time on shit that's useful.
And that would be generated from the like table gen spec if it has it.
Yes.
And then if it's custom, you just have to rewrite it.
Well, yeah. So that's what I was. Sorry. So coming back to your question, custom. So the way that you can generate arbitrary op builders, Python APIs, Python bindings to arbitrary op builders is there. Well, there's a generic form, right? So like, there's always a generic form.
True.
And so you're basically just I haven't tracked this down literally to the last inch, but I believe it is. So it's calling operation state, and operation state is a thing that like incrementally builds up the representation of the op. But I believe it's actually just building up the string representation.
Really?
Like it's not. I mean, because so like I said, I haven't tracked this down to the last inch, but like if you think about it, it makes sense because hey man, this is a parser. This is all about parsing. Like there is no in-memory serialization. There is no serialization. There's no serialization of an op. There's what is the string parse? What is the string dump? It's not a serialization. It's not a protobuf. So it doesn't have fields. It doesn't have members. It doesn't have nested structs. The entire canonical, highly fiducial representation of the op is just the string. The generic form of it, like the grammar-abiding, law-abiding, grammatical form of it, but it's a string. So you're building up the string piece by piece. That's again, I haven't tried this out because there's not fucking other thing that it could be.
I mean, it could match the object model of the operation,
but there is no
built in memory.
Well, so that's what I'm saying. There is no object model.
Sure, there is, isn't it? Like that's why they have all of this, like how the bits are packed in memory. Excuse me.
But that's not that's like a proto. So I'm not trying to be pedantic. I think I've tried to think through this, and I'm like, fundamentally, you can't do that because although there's a machine representation that is kind of like uniform across all of them. Oh, there's the leading results or the trailing objects or whatever. That's not an object model. That's just a layout in memory. That's not, well, that's a generic op, right? So this is exactly what I'm saying, right? The object model that you're thinking of is a generic op. It's a view on okay, I have a polynomial dot from tensor, and then I take an operation star of that. But that's not polynomial from tensor. That's a generic operation that's laid out in memory according to some rules, but I don't, like, the runtime has no idea any longer that it's a from tensor object, except for the name.
Mm-hmm.
So the machine, so like the object itself in memory, there's no way to know other than the name or the type ID, which is the same thing, because the type ID is assigned after you grabbed it from the name. Okay, anyway, we don't have, like, I'll do the last mile kind of, but I forget what it is that happens, but there's a thing that happens on the Python binding side that makes me kind of intuitively infer that, oh, operation state is building up a string representation. There's some error that I would hit where, like, this can only error make sense if it's doing string lunging, but I don't remember the error off the top of my head. And like I said, for the fourth time, I haven't done the last mile. And so none of that, yeah, so there's no type state. There's no type build-up state. There's no attribute build-up state. The only recourse you have essentially is generating, like, getters and setters or something. Or sorry, the only recourse you have is generating CAPI. Like, you can't build up a type generically. You can only take the existing builders that are generated, which are not generic. There is no operation state core. I know, but there are a whole bunch of, like, float 32 get get or polynomial get. Those are generated.
Yeah.
So the only thing that you can do is be like, okay, cool. Let me sprinkle some pixie dust, i.e. CAPI around it. And it's like a diminishing returns kind of thing, because you can't force everything through a CAPI. So, like, if I want to push through stuff like I don't, you can't push through, like, a dense element array through CAPI, for example. Well, whatever, it's hard. Anyway, so none of it exists. It'll be interesting to see how it works out. Where are we at as far as, like, commits? Let's see. Or change files. I'm gonna exit presentation mode for a second. Okay. So we have added this. Oh my God. Okay. Spur exchange. That's a Spur exchange. It's helping somebody. That we haven't gotten to work yet. That's Spur exchange. Okay, so these are the 5 files. Are we missing anything? This is basically, as soon as I figure out why the fuck this is in the wrong place, and all of them are in the wrong place, this is basically the minimal set of things you need. Given that you don't, sorry, you still need, I'm trying to think if this is actually true. You do need a CAPI. I feel like I'm getting sorry. No, sorry, that's the really. Okay. So if you do want types, you need wrappers around your stuff. Yeah. I wonder if I'm fucking something up by doing this. Okay. You need this. You need it in your. You don't need to have it under C API. You can have it in your part of the source tree, right? But this is how, like, how do I get an affine map? Well, I'm gonna wrap the getter, right? Affine map empty. That's the C++ caller. That's the C++ getter. Context is already bound for you. I'm going to unwrap the context. Unwrap here always means give me the C++ version of the C thing. Unwrap the context, call the getter that just takes no dims, no symbols, nothing, and then wrap it again. So what wrap and unwrap do are like, it's right here. It's like opaque, it's like void pointer representation. Void pointer handles, memory location, whatever. So if you want, oh, I want to bind polynomial type and make creation and introspection and all this stuff work, this is what you do. You hide it behind a void pointer, pass it to the bindings to like print aspects of, well, what is the degree? I pass it back to the C API. The C API unwraps the void pointer and then is able to tell me what the degree is and then returns that integer, right? So basic types can go fine. But every time you want to get some feature metadata about your polynomial type, you pass it through the C API, unwrap it, get that thing, and send that thing back. So it's like a one hop back and forth to get something, to find out something. Yeah, I don't know. When I finish this PR, and I will send up this PR maybe tomorrow. I'll wrap. So polynomial is going to be hard to type. Is there anything else that needs to be wrapped?
I mean, there's the attributes. So like